So with this topology, we are going to understand the stub for different network types in OSPF. Stub, totally stub, not so stub, totally not so stub, 4 types. So for the first two, we will use only one external routes, which is coming from router 9 on the right. BGP is going to give us the routes. On router 8, we redistribute it from BGP. The routes we redistribute from BGP to OSPF. So R1 will generate type 4 LSA saying I got router 8 as the ASBR, and R8 will generate type 5 LSA advertising those routes that are learned from router 9 via BGP. Which will be seen in router 3, 4 and 5 as E2 routes. E2 depends on the redistribution type. But I don't see any routes from external. I need to check the ASBR configuration. Let me go to router 8 and check the ASBR configuration. Show run section router OSPF. This is not a new topology for us. That's why I'm going straight to this point. What do we see here is OSPF is not having any BGP redistribution. Show IP OSPF interface brief. OSPF runs on all this loopback as well as F00, but we don't see 89 network, meaning OSPF is not running on F01, is not running on F01 because we want to learn route from eBGP. Show IP protocol. I don't have BGP. Okay, no problem. Let us now try pinging router 9 from here. 89009. If I'm not pinging, then there may be some configuration missing on R9. There may be no configuration or some configuration may be missing. Show IP BGP, show IP interface brief. I have the IP address 8989 2 times. So this is 8989. Right, then let me try pinging now from router 8, 8989 2 times. Yeah, it's pinging. Then what is missing is the BGP. We want router 8 to be in BGP autonomous system 80. And router 9 is in autonomous system 90. Router BGP 80. Neighbor is 89.89.0.9. Remote AS is 90. Right. If router 9 is configured already earlier with BGP, I must say enable. But BGP is not configured in router 9. Let us configure. Router BGP 90. Neighbor 89.89.0.8. Remote is 80. I'm going to advertise these networks 1.1.1.1 mask 255.255.255. Sorry, 255.255.0. Correct mask, because I put this one here. I should put 0. And also we have 2. Let me use a notepad to make it fast. Twelve, 13. Do I have 12 and 13? Yes, I do. Up to 16. 12, 13, 14, 15, 16, and 2, 3, 4, 5, 6, 7, 8. All right, one more. So this goes on route 9. Sorry, 8. You're right. All right, 9. And expecting all these networks to be advertised. Show IP BGP summary. Show IP BGP. Okay, looks like good. Everything is advertised. And R8 should be learning it now. Show IP routes. Show IP route BGP. I have learned only these 3. Why? Why? You know all this learned. Reminder. Okay, it has come. It took some time. BGP is heavy protocol. It is not only advertising the routes, prefix length, it also advertises attributes for each destination. The well-known attributes are always there, like next hop, origin code, is path. Yep, that's why it took some time. Now these routes we are going to give it to OSPF, and from OSPF back to OSPF routes to BGP. So vice versa, we have to do this router OSPF1. Redistribute BGP autonomous system number 80. Include the subnets. Likewise, I go under router BGP 80. Redistribute OSPF1. That's it. As a result, I should have reachability from between R3 and R9. Now if I go to router 3 and type show IP route OSPF. You can see a lot of E2s. These are BGP routes. What is next? I should be pinging this 1.1.1.16.1. Only if I trace the route, you can see it goes to the external R9. Now, if I check the database, I can see type 1, type 2, type 3, 4, and 5 LSAs. Let me show you that. Show IP OSPF database. Look at this. This is router LSA. Type 1 is the LSA comes from every router within the same area. If you see in the same area, you have router 4, router 5, and router 3. Let's say you can see router 3's router ID, router 4's router ID, and router 5's router ID. Next is type 2 LSA comes from designated routers. See, between these two link, R3 is a designated router. And between these two links, R4 is the DR. So we can see the DR providing type 2 LSA. Type 3 LSA is the one which comes from other area. Other area routes will be advertised to you by your ABR. You see, router 5 is your ABR. ABR provides all these other area routes like 8.8.8.8.1.1, 8.8.16.1. And you see from where it is coming. It's coming from your ABR. It's not saying I'm giving you from R8. No, it doesn't say like that. It says ABR gave me. Likewise, 10.16, 10.18, 10.56, 10.18, 10.16, 10.56. These are all other areas. Area 0 and area 500. You also have 111. Maybe here, router 1. And now if you see, this is the router ID of ASBR. ASBR. Who is giving you? Your ABR is giving you. Your ABR will give you the location of ASBR. And if you check it in router 6 will show router 1 as the giver. Let me show you on router 6. Type 4 originates only from ABR. You see, type 4 originates from ABR. You will see router 1's address. Router 1 is the advertising router. Okay, what's next? I can also see router 3 is also, this is router 8's router ID given by router 1. This is router 3's router ID given by router 5. You know why 5 is talking about 3? Because 3, once we redistributed from RIP to OSPF, those configurations are still there in router 3. Even though we don't have any RIP routes now, show run section router OSPF. You see the redistribution is already there, that's why. Let us remove this. Now if you go back to router 6 and check, type 4 should not have this entry. Should not have this entry. Let's check. type 4. This will vanish. We need to wait some time. It will vanish. So to make the impact advanced, I need to, oh, I said clear IPGP, that's the problem. Clear IP OSPF process. All right, now let us, before we go and verify that, let us trace the route. Okay, so which means convergence has happened. Now let's go and check. Okay, it is aging out. Okay, you need to wait. It's aging out. If you notice previously, the age was big. The age was big. It's aging out slowly. Okay, so it will age out. Now what I'm planning to show here is we got area 1000 with both type 3 as well as type 5, obviously type 4, which makes the routing table as well as the OSPF database bigger. You see, show IP route summary. The space consumed by the routing table entries have come around 10,000 bytes. And we have learned 16 external routes. 16 type 5. We can minimize this by filtering type 5. So if you filter type 5 by configuring STUB, the ABR of this area, which is router 5, will generate a default route and give to router 3. And that default route will be seen as inter area, which means this will become 22 when this becomes 0. And if you see the database after configuring, STUB, if you see the database, you will not see these portion. This portion won't be there because type 4 and 5 should be filtered out. You will have one thing extra in type 3, which is before this line you will have a default route also. And the advertised route will be same 5.5.5.5. That's what you're going to see after I finish configuring STUB. Currently, if I check the routing table, show IP route 1.1.16.1, it shows the route. It shows the route and it is redistributed route. Router 4 is the giver of this route. So we can see here the originator is the Asbr. You can see all this info. Now, I will be pinging, but I won't see this route after I configure STUB. If I ping now, definitely it will ping because it has got a clear route. But after I configure stub, when I type this command, you won't see anything. Then how the ping will happen? Using the default route. See, I'm going to configure stub. Before that, I want to make sure that there is no virtual link in this area. I'll go to router 5 and check. Good, there is no virtual link configured. You need to configure the commands tab under router OSPF saying area 1000 is a stub. This has to be configured on every router in area 1000. If you fail to do, the neighborship won't come up between those two routers. So as soon as I hit enter, the neighborship will go down. I want to show you by sniffing some packets. Right now stub is not configured, and if you see the hello packets, OSPF hello packets, this is going from 5 and this is coming from 4. Let's see. In the hello packet, not here. Option field here. You see, external routing, it is capable. Meaning what? It is capable of bringing type 5 LSA. It is capable of processing type 5 LSA. External routing, capable. After I configure stub, you will see 0 here instead of 1. And this must match with the neighbor. If not, the neighborship won't come up. Let me do that first. I hit enter there. Listen. On router 5. I hit enter. After I hit enter, you see again I capture router 5's hello. Waiting. Okay, router 5. Okay, here is router 5. You see, not capable. External routing not capable. Whereas on router 4, it is capable. See, router 4, 45.4 is router 4, it is capable. But router 5, 45.5 is not capable. Because they are not matching, the neighborship will go down. I'll take you to router 4 and show you. See, router 5 says already I got the neighbor down with router 4. And let's open router 4. And router 4 also you will see the neighbor is expired. Show IP OSPF neighbor. Router 5 don't have any neighbor with router 4 don't have neighbor with router 5. It is because of the mismatch in the capability. Router 5 says I am not capable, router 4 says I am capable, then we cannot form neighbor. Birds of same feather will flock together. Router 4 will not accept router 5 as a neighbor. Because router 5 says I am not capable. Router 4 says I am capable. So what is the solution? Go and configure on every router within this area. On every router you say area 1000 is stub. Now if you go back to Wireshark and check, 4 is also saying not capable. I like 5. So the neighborship should come up now. You see the loading to full. But the neighbor has gone down with router 3. You know the reason. Let's close the Wireshark to save some process. Okay. On R3, I have to configure STUB. Router OSPF 1 area 1000 is STUB. What is next? Verification is what we need to do. As I said earlier, if you check the routing table, there won't be routes. See, there is no network in the table. But when you try pinging, the ping will happen. The ping will happen, it is because of the default route. The ping will happen. You see, it happens. But there is no route in the routing table. How show IP OSPF database? It is because of this default route type 3 LSA. See, you cannot see type 4 and 5. There is no type 4 and 5. It's only summary, network, and router LSA because type 4 and 5 are filtered. They're no more. What is next? Let us see the size. Earlier when we were checking the size, I think I was checking in router 3. No, some other router. Router 4, router 4. Did I check in router 6? What router I was checking? Router 4. I think I was checking in router 3. Let's see now. Show IP route summary. You can see here the size is now gone lower. Earlier it was more than 10,000. External routes you saw like somewhere around a big number. Now earlier it was 21 here, now it is 22. Yeah, here it is. Earlier it was 16 external route and inter area was 21. Now the inter area has gone to 22 and the 16 is vanished and 10,000 is gone. Now it is only 7,432. Next. What we have seen so far is filtering type 4 and type 5, which is STUB. The next one is filtering type 3 also. Oh, just
Sir,
one.
sir, router 3, okay, it will not showing to LSA 4 and LSA 5, but router 4, router 5 also same thing happen or it is not, sir?
All router in area 1000 will not show. Let me
Sir,
show you.
please check the R5.
Let me show you in R4 and then I'll take you to R5. Show IP OSPF database. See type 1, type 2, type 3. That's all. You won't see. Listen, area 1000. You won't see type 4 and 5. Okay. Area 1000. And show IP OSPF. Sorry, show IP route summary. Summary. Here also you don't see external route. Now, type 5, sorry, router 5 is also member of area 0. So the answer is router 5 will also filter type 4 and 5, but that filtered database is only for area 1000. Because router 5 has got two area membership, dual membership, there will be two database. In area 1000 database, you will not see type 4 and 5. But in area 0 database, you will see. And in the routing table of router 5, you will see routes. The reason is this router is also a member of area 0. But the database is going to be smaller before comparatively. Smaller than before. Let us go and verify that in router 5. If we check show IP route 1.1.16.1, you will still have it. You will have it. But if you type show IP OSPF database for area, do you have for area? Database. No, so forget about that command now. Let's go to show IP OSPF database. As I said, you will have two databases. One is area 0, which has got type 1, type 2, type 3, and type 4, area 0, and type 5. Now, if you see area 1000, why type 5 is not shown is because this itself is an ABR. This is the place where the type 5 originates. That's why in area 0, you don't see type 5 because this router which I am showing you is an ABR, isn't it? Now, area 1000, if you see type 1, type 2, type 3, and a default route, that's all. There is type 5, this is for not for area 1000, which means this is area 0. This is area 0. Okay. It's not mentioned area 1000. Area 1000 has got only type 3, type 2, type 1. It won't even have area type 4. So there is no even type 4. Sheikh Ji.
Okay, sir.
The next stub type is not an RFC standard, it is Cisco's. And in this type, in the stub type 3 will be filtered. What is the name of type 3 LSA? Please respond. What is the name of type 3 LSA?
It's a local area.
Summary.
Summary LSA. Now for area 1000, in which router the summary LSA originates?
R5.
So only on R5 you need to say no summary, because the other routers have got no rights to deal with that summary LSA. The other router like 4 and 3 has got nothing to do with type 3. So there is no point of configuring the command which I am going to type called no summary. Summary is what? Type 3. It is originating from type 5, sorry, router 5. So only on router 5 you are going to say, this command. Router OSPF 1. Earlier we said area 1000 stub. No. This command area 1000 stub don't remove from 3 and 4. Do not remove. It should be there. And on R5 you are going to say area 1000 is a stub, but I don't want summary. I don't want type 3. So the neighbor is going to come now back. See, the neighbor has come back. Now if you go and check router 4, your routing table will be much smaller. Earlier it was 7,000, no? Now it will be like 4,000 or something, 2,000. The reason is all the externals means type 4, 5 is filtered. Type 3 is also filtered, only a default route. Check the routing, check the database. You got only a default route as type 3. There is no other route. There is no other inter-area routes coming in. So the size of the routing table is also very small now. You got a default route given dynamically. Now from router 3, as usual, you can ping. See, there is no route for the external. There is no route even for the internal. Internal means other area. This is area 500. See, area 16.1, area 500. But if I ping, I'll be able to ping both inter area as well as external BGP with a simplified routing table. See how big from 10,000 something it has come down to 2,000 something. A big change. The summarization can also do this, but not to this extent. The ABR, ASBR summarization that you learned also minimizes the size of the routing table, but not to this small number. You don't compromise. You still have the route to reach, but not the precise route, the default route. You still have the connectivity to other area, though the route is not there precisely mentioned. You are able to ping the external, though the route is not precisely mentioned. The reachability still happens. So we have learned today stub and totally stub. For not so stub area, we are going to bring up the RIP autonomous system. And then when I configure area 1000 as a not so stubby area, you will see there will be routes given by RIP shown in router 4 and 3 with N. N means not so stubby area, type 7 advertisement. The same network, say 1111, which is coming from BGP, will not be shown here because we said not so stubby area. Type 4 and 5 is denied, so this is coming from other area. It is considered as type 4 and 5, whereas this is coming from the same area. So router 3 knows that I'm not so stubby area router. I should not generate type 5. Instead, I should generate those external routes with type 7. That will appear as N in the routing table, not E, N. Now, what if the network 1110.1 goes down on R2? You may expect R4 to reach 1110.1 via BGP. For that, you may need to write a static default route on R5, and you need to use the command default information originate so that router 5 will advertise the default route to R4. If in case router 4 don't have paths to reach some destination via router 3, we'll use via router 5 via BGP. It provides the route. So point to be noted here is not so stub area will not generate any default route. Only we have to do manually. The fourth type is totally not so stubby area. When we configure area 1000 as totally not so stubby area, the inter area routes won't come in, means type 3 won't come in, type 4 won't come in, type 5 won't come in. Instead, R5 will generate a default route dynamically and give to R4 and R3. So you will have a precise route to reach RIP routes in R4 and R3. You will have a precise routes to reach RIP given routes. And for the other area like area 0, area 500, and for the BGP given routes, you'll have one default route given by R5. These are the two stub which is left. We'll see in the next class. I do not want to pressurize you with too many things today. Is there any question or anything that you want to verify in that first two stub that we have learned today?
So only the stub and NSSA is the RFC. Totally stub is not an RFC.
Correct. Totally stub and totally not so stub, both are not RFC. It is Cisco standard.
Okay.
Any other question?